So in the question, a beaker which contained 0.5 kilogram of water at 3 degrees centigrade, so that's the starting temperature. The beaker is heated, the internal energy of a water increased by 21.0 kilojoule. So 21.0 kilojoule, actually it means 21,000 joules. The specific heat capacity of the water is 4,200. So specific heat capacity of water is given 4,200. What is the temperature of a water after it has been heated? Means we need a final temperature. So to get the final temperature, first what we will do, we'll find the change in temperature. So we have this formula. We have the formula for specific heat capacity. That specific heat capacity is equals to energy which we supply divided by mass into temperature change. Temperature change, you can write delta T, that's acceptable, or you can write delta theta, that is also correct. Both ways acceptable. Why I did not use the formula for heat capacity or thermal capacity? Because in the question, specific heat capacity is given. From the unit, I can identify specific heat capacity is given. That's why I use the formula for specific heat capacity. If in the question, thermal capacity, if it was given, then I will use the formula for thermal capacity. But because it is not given, specific heat is given. That's why I'm using this formula. Now just substitute the values. Specific heat capacity is 4,000. So this value of a C is 4,200 joule per kilogram degree centigrade. Value of the energy which we supply is 21 kilojoule, or you can say 21,000. Mass, it's 0.5 kilogram. So first we will find temperature change, and using a temperature change, we will find the final temperature. Because in the question, we don't need temperature change, we need a final temperature. As they ask, what is the temperature of a water after it has been heated? So when we substitute the values, value of C is 4,200, energy is 21,000, the mass is 0.5 multiplied by temperature change, delta theta. We need delta theta, so that will go there in multiplication, and 4,200 will be there in division. So delta theta is equals to 21,000 divided by 4,200 divided by 0.5. What's the answer for this? When you solve, delta theta will be 10, I guess. Yeah, delta theta is 10 degrees. But in the question, this is a change in delta theta, means change in temperature. But they ask for final temperature. So when you are supplying the heat energy, the temperature will rise. So temperature change, the temperature change is final minus initial, or delta theta is equals to final temperature minus initial temperature. So delta theta, the change in temperature was 10. Final temperature you are finding, and initial temperature was how much? Initial or starting temperature was 3. That's why this 3. This 3 is minus, other side it will be added. So the final temperature will be 13 degrees. And even without using a formula, we can simply work out, like if starting temperature was 3 and the change in the temperature is 10. So how much, what will be the final temperature? The final temperature will be 13 degrees. Is it clear, discussion? Any doubt? Okay, question number 5. A copper container of mass 0.2 kilogram. It's having 0.1 kilogram of water. So there's a container made up of copper, and this copper container is filled with the water of mass 0.1 kilogram. The specific heat capacity of a copper is 385 and that of water is 4200. How much energy is required in joule to raise the temperature of a copper container and the water by 10 degree? So basically, we want to change the temperature of the copper container and we want to change the temperature of the water as well. We need a total energy. So what we will do, we will find the energy required. We will find the energy required to increase the temperature of the copper, and we will find the energy required to increase the temperature of water. And at the last, if I need total energy, what I will do, I will get the total energy by addition. So just add the two energies, I will get the final answer what I need. This is a question that you have a container which is made up of copper. It is filled with water. You need how much energy is required to increase the temperature of copper by 10 degree and water also by 10 degree, the total energy. So total energy required is equals to the sum of energy required to increase the temperature of a copper and increase the temperature of water. How to find energy? Specific heat capacities are given. So if specific heat capacities or value of a specific heat capacity is given, so first I will find energy required for copper. The formula for specific heat capacity is equals to energy divided by mass into change in temperature. Why again I use this formula for specific heat capacity? Because that is given. If thermal capacity is given, then I will find the energy by using thermal capacity. So specific heat capacity of the copper is 385. So this will be 385 energy. The mass of the copper was 0.2. And what is the temperature change? 10. So 0.2 multiplied by 10, that will move to other side. So that will be 385 multiplied by 0.2 multiplied by 10. So that is the energy which is absorbed by the copper. And if I need energy for water, the same formula, specific heat capacity is equals to energy required divided by mass into temperature change. Specific heat capacity of water is 4200. Energy is equals to reason why I did not solve this, the final answer, because in the options you can see there's no solution, just the values are written. That's why I did not solve completely. The mass of the water is 0.1 multiplied by temperature change 10. When I multiply, so energy for the water is 4200 plus, multiplied 0.1 multiplied by 10. So this is the energy for the water. This is energy for copper. What is the total energy required? The total energy required is equals to sum. So I will add the two values. So which option it matches with? It matches with option B. Like this is the energy which a copper absorb, and this is the energy which the water absorb, and sum of the energy will give us total energy required for both objects. That's a total. Is it clear, this question? A question 6. A student uses an immersion heater. A student uses an immersion heater to heat some water in a beaker. The water is heated from 20 to 80. The energy supplied is 60 kilojoule, means 60,000. Ignore the heat loss. What is the thermal capacity? What is the answer here? 60,000 divided by the change. Energy is not 60, energy is 60,000. Why? Because it's written 60 kilo. So kilo here means 60,000. And temperature change is 60. What's the answer? So 60,000 divided by 60, 1,000 is the answer. Is it clear, this question? Just a direct question, so you just have to use the formula and get the answer. Now this is a similar question. You need in this question you need increase in temperature. Solve. What could be the answer for question 7? Question 7. Look, one more thing. There's one more point. The unit conversion is always important. You can see here it's written 250. It's written 250 joule per kilogram degree centigrade. So if specific heat is joule per kilogram, then this mass should be in kilogram. Don't forget to convert grams into kilograms. So C is the answer for, like, how you solve. You have the formula specific heat capacity is energy divided by mass into change in temperature. Sometime I'm writing delta theta, sometime I'm writing delta T. Reason is only that you will not be confused. Both of the symbols can be used. So specific heat is 250. Energy which we supply is 5,300. The mass is 0.8. Why 0.8? Because it should be in kg. If this value is in joule per kilogram, mass in kilogram. If this sometime this is in joule per gram, that case the mass should be in gram. And you're finding delta theta. So when you solve, so delta theta is equals to 5,300 divided by 250 times 0.8. So you're getting C as an answer. If it is like example 26.5, yeah, so it is an estimation that it is approximately 27. Same quantity of thermal or heat energy is given to two objects X and Y. So example, you have two objects X and Y, two different objects, and you supply same amount of energy. I'm just using the question to draw a figure so that you have a better understanding. You supply the same amount of energy. You can take any value. Example, here you supply 100 joules. Here also you supplied 100 joules. Then what happened? The temperature rise of X is less than Y. Means example, for X, the temperature changes from 20 degrees to 22 degrees. And for Y, the temperature rise of X is less than Y. For Y, the same temperature initial but changes higher, like from 20 to 25. Which statement is correct? First, about the thermal conductor, these two cannot be an answer. Why? Because the term thermal conductor can only be understand like if you did an experiment, if you put an object here or a wax and it melt from other side. So there should be a time interval to identify whether they are thermal conductor, better thermal conductor. So it does not give an idea. So you're left with only option A and C. So which one is having a higher thermal capacity? The thermal capacity, X is having a higher thermal capacity. No, the thermal capacity, the formula for thermal capacity is energy divided by temperature change. So in the question they mention you supply the same amount of energy. But for X, temperature rise is small. So thermal capacity and temperature change are inversely proportional. So if you supply the same amount of energy, the object which shows a smaller change in temperature will have higher thermal capacity. Means for X, we need more energy to cause a 1 degree change in temperature as compared to Y. So A is the right answer. Is it clear? This question? So this I gave an example also when I was explaining a topic that when you have two objects, you supply the same amount of energy. The object which shows a smaller change in temperature will have a higher thermal capacity.
Sir, I have a question.
Related to previous?
Yeah.
Okay. Yes.
Sir, the thermal conductivity, is it dependent on specific heat capacity, like in any way?
No, actually, yeah, there is a relation, but not direct relation. Like indirectly, yes, they are related. But thermal conductivity actually depends on the internal structure of the material. Like example, all the metals are conductor. All the metals can allow the heat energy to travel from one place to another. But some metals have a greater capability to conduct heat than the other. So actually it depends on the size of the positive ion and the number of the electrons available in the structure. So thermal conductivity depends on the number of the particles, free particles within the structure.
Yeah, so it's like not obviously connected.
Yeah, that's why I'm saying indirect, there is a connection, but direct connection is not there. Like maybe an object may have a higher thermal capacity, but may not be a good heat conductor,
Yeah.
or lower thermal capacity and good conductor. For example, when you're comparing copper, aluminum, you find all are metals, but they have different thermal conductive specific heat capacities as well.
Yeah.
So better not to go that part, like relate specific heat with thermal conductivity. Like consider they don't have relation. Indirectly, yes, there is a relation, but directly you cannot say.
Yeah. Okay. Got it.
In question 8, specific heat capacity. If for Afif, if option like if involving a specific heat capacity, then they should mention the mass as well. Without mentioning a mass, you cannot compare the specific heat capacity. So, example, uh, the diagram shows 4 blocks of steel. So you can see all are same materials. So you have block of steels, same amount of heat energy supplied, and they mention which block shows the greatest rise in temperature. So how you can relate? You can use the formula. First thing, can you identify which object is lighter here? A, B, C, or D? Which is a lighter object, like small mass? So A mass
A.
is smaller, and the heaviest it looks from the scale, D looks the heaviest. When I use the formula for specific heat capacity, so when I use the reason why I'm using a specific heat capacity, because the temperature change is not given. They mention we give them the same amount of energy, but temperature change is not given. So I cannot compare their temperature change. Or sorry, if we supply the same amount of energy, but the thermal capacity, because we have the formula, specific heat capacity is energy divided by mass into change in temperature. So I can have a relation between mass and change in temperature because they are made up of steel. So specific heat is constant. We give them the same amount of energy, so energy is also constant. So what is the relation between temperature change and mass? When I just rearrange the formula, so you can see temperature change and mass are inversely proportional. So the one which will have a lighter mass will show a greater change in, or smaller mass will show a greater change in temperature. So which object will show a greater change in temperature? So A will show a greater change in temperature. And even without calculation, even if you understand the thing, like it's a small object, you supply the same amount of energy. So obviously the small object cannot store greater amount of energy. So its temperature will rise more for every 1 degree, for every energy provided. Question 13. A heater supply 80 joules. A heater supplies 80 joule to a block of metal. The temperature of a block rises by 20. What happened to the block of a metal when its temperature fall by 10? 80 joule is causing a 20-degree change in temperature. Like if there's a block of a metal, you're supplying 80 joules, and this is causing a temperature changes 20 degrees. Now in the question they say you have the same block, but now the temperature fall is 10 degree, like decrease in temperature is 10 degree. So if temperature is decreasing, you remove the internal energy. How much internal energy must be removed? So if 80 degrees causing a 20-degree change in temperature, so 40 degree will cause a 10-degree change in temperature. And what happened to internal energy? When you supply energy, internal energy increases. When you remove energy, the internal energy decreases. So A is the right answer. More examples, questions we'll do tomorrow. Any question or a doubt related to the class today? Today we discuss specific heat capacity. Tomorrow we'll discuss latent heat and do more questions related to the topic. Question 13. Look, in question 13, when you supply energy, the particles take energy, so internal energy increases. So what you can do, you can first find the thermal capacity of this object, this block. You have a block, you supply 80 joules, and this cause a temperature change. The temperature of a block changes by 20 degrees. So how much, the question is, if we remove the energy, we remove the 40 joules, sorry, if we remove the energy or we decrease the temperature or the temperature fall by 10 degree, which statement is correct? So when we supply energy, the particle gain energy. So what happened to internal energy? The internal energy will increase. When we remove energy, what happened? The internal energy will decrease. Because when we remove energy, the particles will have low energy. That's why the internal energy is decreasing. So when you supply, internal energy increase. When you remove, the internal energy decrease. So first thing, cancel out the two wrong options. So C and D cannot be an answer because we are removing the energy. As we know, the temperature fall. As the temperature fall, it means we are removing the energy. But how much energy we should remove? So you can simply use the ratio or you can use the thermal capacity. If 80 joules is causing a 20-degree change in temperature, so then 10-degree change in temperature is caused by X. Cross multiply, simple ratio, when you multiply, you will get 40 joules. So means how much energy is removed? A 40 joules of energy is removed. That's why A is a correct answer. So today we discuss specific heat. Tomorrow we'll discuss latent heat and experiments related to specific heat and latent heat. So I'll end the session and share the recording with you.